Hello and welcome to this video on the transit method. This is the second method that we're looking at, second method for finding exoplanets. So you just finished your section on radial velocity and astrometry. So it's time to move on to the transit method. So the transit method is a method that finds exoplanets by looking at a star, the brightness of a star. The exoplanet is discovered when the star dims. What's causing the dimming of the star is that a planet is moving between the star and us, the observer. And when the planet moves between the star and us, the star will dim. And it is that dimming of the star that tells us that there is an exoplanet present. Now, some stars do dim and brighten on their own. So an astronomer would have to determine first that the dimming and the brightening of the star is not because of the star itself, that it is in fact a planet. Now, the instruments that are used to find these exoplanets have to be very sensitive because the amount of dimming effect that's occurring is not very great. So the instruments have to be extremely sensitive to find that. We do have telescopes in orbit that are discovering these planets. The Kepler Space Telescope uses the transit method to find exoplanets, and the Kepler telescope has found thousands of exoplanets. All right, so let's take a look at this method with a little more detail. This is the type of data that scientists receive when they're examining the light from the star. They can't actually see the planet moving in front of the star. They have instruments that detect the light output, and the data is converted into graphs like the one you see on the bottom of the screen. And you can, if you just watch the graph in relation to where the planet is on the star, you can see that as the planet moves across the edge of the star, the brightness graph dips dramatically. And then as the planet's moving across the face of the star, that's that lower region right here, this region of the graph. And then as the planet moves off the edge of the star, you can see that the brightness increases again here and goes back to the normal brightness of the star. So the shape of the graphs vary depending on the size of the star and the size of the planet. We'll look at that in a moment, but let's take a look at this diagram. This diagram is showing the same thing that the previous animation showed. Here you see the positions of the planets relative to the brightness graph. This is showing the brightness of the star only. The planet has not passed in front of the star at this time. But at position 2, you can see the planet is beginning to move in front of the star, so the brightness of the star dips a little bit. And then at position 3, the planet is fully in front of the star, so we have the greatest decrease in light. And then over here, as the planet moves across the face of the star, you can see that the light curve increases again and back to normal. So these light curves do change their shape depending on the size of the star and the size of the planet. The three examples at the top of this diagram show different size stars and the same size planet. And the diagram at the bottom is showing same size planet, different size, reverse that, same size star, different size planet. So let's take a look at the bottom one first. Here we have the stars are all the same size and the planet is increasing in its size. So notice that the width of the graph is the same for all of them. That width relates directly to the size of the star. Notice that the dimming is least when the planet is smallest, and then the dimming increases as the planet gets larger. So the larger the planet, the more the dimming is created. Now let's go ahead and look at the top set. And in the top set, the planet is the same size, but the stars get smaller. Notice the width, the light curve width is directly related to the width of the star. And here, this star is smaller, so the width of the brightness graph is not as wide. And then the smallest star, the smallest width. Notice that we're looking at the same size planet, so the effect is that the dimming effect is greater as the star gets smaller when your planet size stays the same. All right, so what are the pros and cons of the transit method? The pros are that this can work on faraway stars. Our instruments are sensitive enough to detect dimming at great distances. We can also detect terrestrial planets. The method is sensitive enough to see the dimming that a terrestrial planet would cause. And remember, a terrestrial planet is a planet like Earth. It could be, it's anything from Mercury size to 10 times the size of Earth. Another benefit of the transit method is that the atmospheres of the planets can be determined to some degree. The other day we learned about spectroscopy, and you learned about dark line spectra and bright line spectra. A dark line spectra is the spectra that's emitted by the star, and the bright line spectra is an emission that's also emitted by the star, but what's being picked up are elements that are being absorbed by the light of the star. So these elements are, if the sunlight or starlight passes through a planet's atmosphere, it will pick up the composition of the planet's atmosphere, and we'll be able to detect that by analyzing the spectrum, the bright line spectrum. So that's really a cool benefit of this particular method. It's the only method that we can learn about the atmospheres of these planets. So if you hear that an exoplanet was discovered with, for instance, water in its atmosphere, that particular exoplanet was probably discovered using the transit method. Cons, the angles have to be exactly aligned to detect a planet. The star and the planet and the observer needs to be directly in line so that the planet transits in front of the star. And just like the other methods, the process is slow. Scientists need to observe several orbits of the planet around its star so that they can verify their data. They're not going to announce that they found a planet after seeing one transit. They will watch several transits so that they can verify their data. All right, that's it for the transit method. Thank you for watching this video.